Okay, so we're going to talk about something new today, and it's basically something that we haven't talked about before, and we're going to try it today. So it's going to be a new topic because we're doing a new project. And so first, we're going to start off with a few basic questions like what is an X-ray? So great. Immediately, I found out something that I've kind of forgot is that what an X-ray is actually doing. So what it's actually doing. But essentially, it's basically taking a scan of your body, a scan of your entire body, and then depending on the material or matter, the density of the material or the matter inside of your body, the whatever particles sometimes gets absorbed and sometimes passes through, and then it results in the final project being a how do you call this in English? A sector, and then it's basically a cross section of the entire body. So basically, what it's doing is that is kind of compressing 3D image into 2D space. So so yeah, it's losing some information, but it's also the easiest way to kind of look inside of your body to actually find to actually look at where like tumors are and where people where things are, and just things that are denser are just harder to pass through, for example like bones, and they're going to show up as, let's say, white on the x-ray kind of board. And so there are some limitations, and you're definitely going to figure out that while compressing 3D space onto a 2D plane is definitely is going to result in some loss in information. And that information basically stops you from telling, well, where is this tumor? Where is the heart in the depth of the human? Where is it? You only know, oh, it's at this position, but where? How deep is it into the skin? You don't know. And then you can't really tell the soft tissues apart because they all are made up like the same elements, carbon, hydrogen, and oxygen, and they basically just pass through pretty quickly, and then they pass through pretty decently. Okay, so now we know the limitations is that we basically don't we know we know the position. We don't know the kind of depth. Great. I don't know how to spell. We don't know the depth, right? And so to kind of cope with that, people have come up with something called a CT. CT is called computed tomography. And again, I have forgot to search what tomography means. And so basically what this does is that you say that, oh, well, one X-ray image doesn't really do the job. Well, let's just take multiple. And we kind of, every X-ray is a cross-sector, so we kind of just take like a bunch of cross-sectors around the body, and then we kind of morph it into like a 3D sculpture. So that's what CTs are basically doing. So if you look, it's just a giant spinning machine that puts X-ray all over the place, all over your body. And you kind of pass through this, and then you go into this, and then this thing spins. Yeah. So it takes many photos from many perspectives, and well, this gives you basically depth, and then it gives you a lot of the syndromes that you would need. And so, but it also kinds of it can show the depth now, but it also kind of fails to tell the soft tissues apart because they once again still have the same, well, let's say same pass through identity, if you will. And then it's getting better. It's 3D, right? We can see a lot more. We can see the depth. We can see with the position, and then yeah, and then so if we want to tell some of the soft tissues apart, for example, things in your brain, things in your spine cord, the whatever those are called. I don't really know them in English. So now we're going to use an MRI. So MRI is basically no radiation. It's using the fact that water is kind of magnetic. I believe it's called 极性分子吧. So which means that it kind of, so it's not what do you call this? It's not symmetrical. Okay, it's not symmetrical, and then it kind of has a magnetic ionizing at inside of it. And so the hydrogen atoms are basically going to become uh, are going to spin with the giant magnet that the MRI has. And then there are some hydrogen particles that are not going to spin, and they're called low energy water molecules. And then we're going to send radio waves to make them spin. So, for example, this is a water, and then these are just going to spin in like a direction. There also are like hydrogen particles that are not going to spin, and these are called low energy water molecules. And then we use kind of radio waves to make them spin. And then once the radio wave stops, they're going to stop, and then this low energy water molecule is going to release all of the information. It's going to release all of the energy that it absorbed with the radio waves, and then it can tell us where it is. And so this is how an MRI works. And yeah, so now we kind of know the differences between X-ray, CT, MRI. And then X-ray is 2D, CT is 3D, MRI is 3D as well. And then X-ray gives you a good, cross sector, and then CT gives you kind of a 3D image, and then MRI gives you a better 3D image. Okay, and so yeah, and we're trying to like compute an AI for for inspecting tumors, and so the first thing that will probably come to mind is that, well, why don't we just use CNN? Well, it's basically I forgot the full name of CNN, but it's kind of like a computer network that if you put in like something, if you put in like an image of a cat, and you train it with enough images, with enough labeled images, it's going to give you, okay, this is going to be a cat. And so why don't we just sort of use CNN and give the computer, let's say, a CT scan, and then say, oh, where's the tumor? Well, there's a few kind of questions. They're all pretty related to the core of like medical research. The first one being that, so CT scans and to identify tumors are pretty hard, and then the only people that we can get high quality graphs from are actually from professional like medical assistants and medical experts, but not a lot of that information is online, and it's just hard to access, and it would be expensive because you're kind of taking up their time. And so the second one is that it's not just in 2D. A lot of these CTs and then a lot of these MRIs are just in a higher dimension, and then there's also kind of like a weird format to them. There's also, okay, this is bad. I forgot to press record on my iPad. This is bad. Okay, so I press record on my iPad, and I'm not going to re-record that. And so there's also going to be the question that different CTs from different places, different positions are not going to look the same. And so it's just hard to do everything. And then there's also a lot of the things that you would need on this AI that a normal CNN would be able to give you. Like, for example, it needs to give you reasoning, at least to give you like circling the brain tumor and a lot of that stuff. And so that's just something that a regular CNN cannot do. And speaking of CNNs, I would need to actually kind of understand CNNs better. I need to understand CNNs better, and I'm giving myself a lot of tasks, and that's something I should have done. And so I can decide to keep on going, or I can stop now. And I've decided to stop now.